Welcome everybody to the fairly regular WebGL Developers Meetup, San Francisco edition. I'm Tony Parisi, co-organizer. There's Damon Hernandez, co-organizer, There's Marina Berlin, she helps with all the logistics.
Bravo.
She helps me with my life, she's my wife. And welcome everybody. I hope you're clapping for her because she's awesome, not because she's my wife, but anyway.
She's so awesomely tolerant.
Tolerant, exactly. She is a saint, the woman.
WebGL widow.
She's kind of a WebGL widow. So tonight we're actually here to talk about something that's one of the deeper technical topics we've ever had, subdivision surfaces in WebGL. Before Joe Eagar, our featured speaker, goes on, we're going to have a few announcements and have an introductory speaker. So let's start with announcements. On September 25th, save the date, I will be posting another page for another meetup for this group. It's going to be about declarative 3D. So imagine if you could do your 3D using markup, not just writing JavaScript code. I'm going to be presenting my GLAM project, which I sort of teased people with at a previous meetup. We're also going to see if the folks who do X3D-based markup, X3D DOM, can come and join us. And that should be really fun. And I've had some offers for sponsorship, so it might be possible that it's catered and a little more upscale than last time. I don't know how fancy it's going to be. But, you know, we might get really ritzy on the next one. We'll see. So September 25th, just save the date for now. I'll post something in the next couple of days. Damon, I think you wanted to announce something about the AEC.
No,
I'm sorry, the VR hackathon.
Yeah. So there's a virtual reality hackathon October 17th through 19th. There will be some WebGL categories there with cash prizes and others. So so check it out. Pretty cool sponsors: Autodesk, Unity, variety of others coming on board.
League Motion, maybe?
League Motion is going to be
Cash prizes?
Yeah, this is going. Yeah, cash prizes, man. We go fancy. So yes.
Is it right around here?
It is going to be at GAFTA. They have their new space, so they are over in the theater in the Mission now.
Okay.
So it's going to be Friday, Saturday, Sunday. There is
Later in October, right?
I'm sorry.
Late October.
17th, 18th, and 19th. Anyways, yes, Dave.
Is there a website we should sign up at?
Hey, love this man. Okay, so vrhackathon.com. It's super simple. Go sign up. So please come. It should be lots of fun. Check it out.
Done.
Damon, when's the next AC hackathon?
Oh yeah, and for anyone interested in the building industry, they are very much big fans of 3D for obvious reasons. The next AEC hackathon is actually going to be in Seattle. That is 12th, 13th, and 14th. So if anyone is up there, that one's going to be pretty cool. Unity is a sponsor, Unreal is a sponsor, so we'll have some of that to give away as licenses. Multi-trillion-dollar industry, definitely need the help of people who understand 3D graphics. And also at the Seattle one, a company called VRAM is going to be there, which has the full motion tracking heads up, so you're in the VR space and you can move around for. But anyways, so
Thank you, Damon.
yeah.
I don't know if everybody got a chance to try democratized virtual reality.
Democratized.
And a $25
Not valued at $10
headset
billion.
attached to your phone, but Teo's hanging out up there, and afterwards, if you didn't get a chance earlier, make sure you get a demo of Google Cardboard. Google came out with this cardboard thing. Now, do you have the originals or the Dodo cases?
These are all unofficial.
Okay, so these are the Google ones, right?
No, not Google.
Oh, they're not?
They're unofficial.
They're called unofficial.
What?
They're called unofficial.
That's another
Yeah, it's
kit.
another brand. It's
Not
another
enough
brand.
cardboard. I didn't know about that. So you've got an unofficial cardboard kit here where you can experience virtual reality. How much does it cost?
$22 for the big one that takes eyeglasses.
And you put your phone in, you've got VR.
And it's
So make sure you check that out if you haven't. It's
And if anyone does buy
The Dodo
one,
case.
you can also go to my blog and download the STL file to 3D print the centerpiece here that will bend, just for what it's worth.
That's awesome.
So, yeah.
Nice. And Dodo case will start showing up at our meetups and giving away some of these and all that in these hackathons.
One of the differences between
$25
Dodo case needs to learn from unofficial is that this one has got a sort of a strip of plastic here. So it doesn't absorb all the sweat from your forehead.
They have it now. They have that now.
Okay.
Yep.
Well, they probably learned that from official.
Well,
Yeah, they're
I'm
making
great.
some new improved
Okay.
cases that they'll be unleashing on the world.
And what we need are
soon.
head straps and things like that.
All that stuff. They're thinking about all that. It's early.
Okay.
That's great. So make sure you check out that material.
Okay.
I remember to have one more save the date, which is October 8th, I believe. Just stay tuned. This one's going to be in the South Bay. So if any of you folks have been commuting out from the South Bay or the peninsula, Amazon's going to host one for us. We're probably going to get WebGL Meetup. We're probably going to get mostly South Bay folks. But if you happen to be down there, you're meeting in Mountain View, hanging out at Google, whatever, you happen to live there, this will be a little more convenient for you than having to come up to the city. I've even thought about, trying to solicit somebody on the dev list to just get a group going down in the valley, right? Because we don't have Henrik's dev camps anymore. There's nothing to fill that void, and everyone has to come up here. It might be nice to kind of spin off a chapter that's just working down there for people who live down there, because I know it's not convenient for South Bay folks. So anyway, Amazon's going to host one of those. They're going to show off some cool stuff with Kindle Fire HDX. We'll see. They're going to tell me, and I'm going to announce the thing when they tell me what they're going to talk about. But that's going to be like October 8th.
Can you ask them to, or can you arrange carpools on the meetup site? Because I'll drive people from the Caltrain.
All right, we'll do that too. That's great.
Awesome.
So stay tuned for both of these new meetup announcements in the next 2 or 3 days. Does anybody else have announcements before we get into our speakers? Thibaut.
We're hiring. For those who don't know me, I work at Artillery Games. We're making AAA RTS in the browser using, our own technology on top of WebGL. And we're currently looking for a engineer / graphics programmer. So if you're interested,
Safe to say, at least from all outward appearances, the best fucking WebGL game engine that's out there. I will say that, Thibaut. Even when you're not in the room. I will say that. I mean, there's some other good ones, but I mean, what I've seen of the stuff that you have running in the game you're building, and the pipeline you showed off in some of these demos where you can just update a JPEG and the game just updates. I mean, there's all this really cool stuff the engine dev tools have, and so I think the world will be well served whenever you're ready to release the tools. But meantime, they're working on this killer game, and yeah, if you're looking for a game development gig, talk to Thibaut.
So what's the website?
Artillery.
Artillery.com.
artillery.com.
Great stuff. Any other announcements?
Just logistics things real fast. The bathrooms are right out here, so if you guys want to either go out the door that's back there, or if you just want to come this way, you just go out the door and it's in the hallway. That's where the guys' bathroom is, and ladies for the two we have. So.
Great. Okay, so we're ready for our speakers. Before Joe Eagar comes up, we're going to do what we usually do, which is going to have Ken Russell give us an update on WebGL, and he's going to have a lot of cool things to share. For those of you who are new to the meetup group, Ken is the chair of the WebGL working group at the Chronos group, which is the consortium that standardizes the WebGL API. The WebGL specification doesn't happen without a lot of people, but essentially the process of creating the technology that goes into the spec is lorded over by this man here, and it's probably the wrong verb.
Yeah, it's no
More like a shepherd than a lord.
Yeah,
Or like a caretaker.
Yeah.
But,
herding cats.
there's sausage getting made, cats getting herded, Ken has to do it. And by the way, I guess you're not doing this on a daily basis right this second. For a long time, he was building the WebGL implementation in Chrome. So he's a motherfucker of an engineer too. Really great, really great. He's a killer team he works with there. And we wouldn't be where we are without the work you guys do, so thank you. And Ken's gonna share a WebGL update that includes stuff from SIGGRAPH, some cool new demos, and some updates on the new spec. Yeah, great. Come on, Ken.
So that was too generous an introduction. But anyway, hi, I'm Ken. Say hi later, please. All right, so what's going on? There's been a lot of activity on the WebGL 2 spec. All of you are eagerly awaiting all the new features that are already in your mobile phones that just aren't exposed to the web browser yet. And we're trying to get to the point where the features are exposed in a way that are safe for the web, and you're not going to crash your phone by being able to just visit a website, and that they behave the same on every phone and in every web browser. So anyway, there's a lot of work going on there. A lot of contributions from NVIDIA and other companies. Really nice stuff. As we at Google are working to make sure that we never break WebGL again, and this is more of a process than you would imagine, but Chrome is getting more and more stable, I would say, as a result of testing WebGL on an ongoing basis. So every commit that goes into Chrome now runs the entire WebGL test suite. So we never break WebGL, which is good.
You're saying any commit in Chrome. Like if
Every
someone
commit.
changes the
If they change the
HTML parsing engine, anything,
it still runs the
bug
WebGL
fix,
test.
anything. Wow.
Every commit is going through the
Awesome.
WebGL conformance suite. Yeah, that was a big step. I think it happened since the last meetup. If not, I'm giving you old news, but we're still going through that process. First browser vendor to test every change against WebGL. All right, anyway, so all that's boring. So SIGGRAPH was great. There was a Birds of a Feather session for WebGL. About 200 people showed up. It was awesome. A lot of cool demos. The demos are on the wiki right now. So you type WebGL wiki into your favorite search engine.
Alter Vista.
Yeah, or, you know, Bing, or I don't know. Then you'll, well, I don't know if you type into Bing, you'll probably get the WebGL public wiki. The first thing that we showed at the Birds of a Feather session was NVIDIA's new Shield tablet, which is an 8-inch tablet with a Tegra K1 graphics processor. This is a desktop class GPU in a tablet form factor. It's freaking amazing. Please stick around and try it later at the end of the meetup. But I'd like to show just a couple of quick
And
things.
those are for sale at NVIDIA.com?
Actually, I got this on newwave.com. That was the best price. So these are already available through online distribution.
How much do they retail for, roughly?
$299.
Oh, that's great.
Yeah, so I mean, I paid for this out of pocket. Google didn't, sponsor it, and it's a fantastic device. I mean, good for everything that you want to do on a tablet, as well as doing desktop class WebGL. So let me show you just a couple of things. NVIDIA got up and showed at the Birds of a Feather session the classic WebGL Aquarium demo, running very smoothly. But what is new is that on a mobile device, it can run 2,000 fish at 30 FPS, which is a lot of geometry. All right. They also showed Altered Qualia's instanced WebGL Cubes demo, which, once it's done uploading data, this is, 150,000 cubes simultaneously, 1.8 million triangles, 30 FPS again. This makes every other mobile GPU choke, honestly. So now you're finally getting desktop class, geometry processing on tablets. Freaking amazing. Pretty much all of the demos from SIGGRAPH, which are, again, all linked from the WebGL wiki, are running really well on this thing. Let me show you a couple. So, you heard of Sketchfab? Yeah. Okay. So they launched a physically based rendering engine backend. Okay, this thing is amazing. All right, so look at this. I hope that the Wi-Fi is good here, so it should work. Working?
Everybody in the back see this stuff?
Can you come a little bit closer, Dave?
Yeah.
Physically based how?
So that is an excellent question, which I do not know the answer to. I think that they are doing.
I can speak a little bit about it.
Can you? All right, fantastic.
It's based on image-based lighting, IDL. You basically render a cube map of the environment, and then you use that as your lighting data, where you're computing the usual Linfong thing. Except it's not Linfong; it's a more physically based equation, which is slightly different. First, there's definitely a Fresnel component in it, but it's much more expensive in terms of graphic sheet.
How are they doing the textural detail WebGL?
So they probably don't. They're probably using multiple textures, so, like multiple cube maps. Because we don't have texture. We don't have text files. So probably multiple. Yeah, I'd say multiple cube maps, which is just like.
And if you add cardboard equal 1 at the end of any Sketchfab model, you have a cardboard version of it.
Huh.
They're doing that now? That's
Yes.
good.
Moly. All right, we got to try that at the end.
Okay,
See if
question mark, cardboard equal 1.
Let's try it
Yeah,
in your cardboards later and see if this stuff actually. Yeah.
Right, because there are 7-inch cardboard viewers.
No. This is the end of all productivity at work. Thank you. No, I really didn't know how this stuff is implemented, especially not in ES2. Stephen Wittens of ACO.NET fame, who's done MathBox, had a really amazing demonstration where he's figured out a way to describe visual effects using markup, and he generates the shaders to implement them. Just one little demo of his is this instanced.
Is he really a human being?
Yeah, he really is.
Okay.
Yeah,
we had dinner. So this is just a bazillion transparent arrows being rendered super fast, and it works actually really well on any mobile device because he super optimized the WebGL code for it, but it runs really great on this NVIDIA Shield tablet, which you should all come up and try out later. But one last thing that I've just got to show you is, so you may remember that Google Maps was rewritten using WebGL over the past year or so. It was finally released. And they, the team did a little bit of work several months ago in order to get it working on, say, the Nexus 4, Nexus 5, Nexus 7 devices. But with no additional work, it's running very, very well on this Tegra K1. And what I got to show you is the Earth mode. It's just amazing. So you know that they've got an Earth mode built into the Maps app, okay? Just tap the Earth icon. All right, and then you're in 3D. And if you come in here and come downtown, for example, all right, yeah,
Sweet.
and then,
Make sure everyone on that side can see it too, Ken.
all right, and then go into tilt mode, all right, and then zoom around the buildings, all right, it's just amazing, just beautiful, all right. Sick, exactly, and this is a web page. Who would have thought that this, okay, and these guys have been working on just beauty in the rendering algorithm. And so you can come out here, zoom all the way out so that you can see the entire Earth. The flickering is bugs in Chrome, so no, it's, all right, and then all of a sudden you can see like the night sky and the Milky Way behind the Earth, and astronomically correct, position of the sun. Come up and try it out. It's an amazing device, and we're really starting to see what you can do with interactive 3D on the web. So I'm super psyched. Any questions?
It has a pen.
Yeah, it does have a stylus. The stylus is cool. I haven't been able to put it to use. I'm not an artist. All right, awesome. Any questions?
Yeah, I mean, it's Android 4.4 or something like that.
Yeah,
Well,
it's KitKat,
It's KitKat.
which is I think 4.4.
Okay. And will it be kept up to date? I mean, is this one of the things that will be almost automatically keeping up to date with the latest revisions of Android?
I hope so. NVIDIA didn't customize the Android experience or super customize it. They have some pretty cool stuff on it, the NVIDIA Grid, where you can stream games from their cloud onto your tablet. Pretty cool. But it should update easily because they didn't mess around a lot with this.
Okay, right. Good to know.
So anyway, I can recommend it. Personally recommend it. Any questions?
You mentioned number 2.0, Tony?
WebGL 2.
2, right.
Yeah, we're working on it. It's being actively worked on.
Okay.
So tell folks about that. Like, what can you share at this point?
Well,
ETA?
I'd love to share an ETA ASAP. It's more work in Chrome than it is in some of the other browsers because of the security architecture. Firefox is making good progress. We're all trying to work together to get the spec in good shape, to get the conformance test in good shape, and it doesn't matter who gets there first in some way, as long as sort of every browser eventually gets there on all platforms. So, given that Firefox is already shipping prototypes, I would encourage you all to, try it out. Try out the new features that are there. Try out, transform feedback and like a new shading language, and see if you can extend your applications with that feature set. I hope that what's going to happen is all the browsers are going to get there in 6 months or so, having viable implementations. It'll probably be another 6 months to shake out the bugs in those implementations, get the performance tests working. once we get there, then it's hopefully a small step to get compute shaders that are in ES3.1 into the spec. That's everybody's big dream, because once you can harness the real compute power of the GPU on the web, really portably in the graphics architecture, then and on mobile devices, which is key, then you're really opening up the floodgates for some awesome content.
I have a question just about, is Google collecting some data about WebGL support on their, on like all the computers that have Chrome installed?
Well, for people that have opted into crash reporting, there are some statistics gathered, but
Is there any plan to open that?
I don't know.
Okay, so the question, the concept behind that is that like WebGL stats is not as accurate as it used to be.
Yeah.
And we're really reliant on that. And I wonder if like there could be a Google initiative or something to like open some of that data if you have it.
Why don't you talk to me afterward, and I will bring that request back to my own management and see what we can do. Yep, it's a good point. Anything else?
Kronos announced that they're kind of like rebooting the whole OpenGL API, I suppose as a response to Mantle and Metal API from Apple. I suppose they should, but how is that going to affect WebGL and the long-term trajectory?
Well, I mean,
Can you repeat the question?
Yeah. So the question was, Kronos is trying to reboot OpenGL in response to competition from AMD's Mantle API, which is much lower level, but is
Whose API?
AMD's.
Oh, right. Okay, right.
Yeah, and Metal, which Apple released not too long ago. And Kronos is, I wouldn't say responding, but is stating that there are efforts underway to try to standardize something, so you won't have to write your application 3 times, once for Apple's iOS and once for AMD GPUs, and then once for everything else.
We've been there many times
been there.
in the last 20 years.
Exactly.
Many times.
I mean, history repeats itself, and people forget how hard it was when 3DFX had Glide, and what were some of the competitors? I mean, I vividly remember this because we lived through it.
Glide was the one that came to mind. It'll come back
Lost
to
in
me.
the mist of time, right?
Lost in the mist of time.
So it's in everybody's best interest to have a low-level but still portable API. It's really key. So that's the intent here. And like I say, as the WebGL, shepherd, or whatever you want to call it, our goal is to make sure that you don't have to write the content twice. That you can write it and it'll run great on your mobile devices and it'll run greater on your bigger GPUs. Okay, and we're giving very direct feedback in the Kronos working groups, in that direction, and we'll continue to do so. And if you guys have feedback about what you want to see or definitely don't want to see as a side effect of this, please, post on the public WebGL list, talk to me, talk to the other people that are in the working group.
So that was almost kind of my question. I mean, what is the participation of Apple and Microsoft in the work you're doing? And you've answered some of that.
Yeah, Apple still edits the spec, so Apple's involved.
Microsoft just joined Kronos. That's good.
Yeah.
So, are they participating in WebGL in that working group now? Have they actually sent someone over? I mean, Kronos is a big place. There's lots of things going on.
I mean, it's probably not appropriate for me to talk about like the active participation on conference calls and stuff. We try to do most of the work in the open. Yeah, but there's a very open, very fluid dialogue at this point, and they've got a great implementation now. They're really pushing WebGL and IE, and they've got Google Maps running in IE 11. Who would have thought that would ever happen? But holy crap! So
and they have sick graphics IP. I mean, they have wonderful graphics people up there, right?
Yeah,
they can only help if they're coming in the spirit of cooperation.
Yeah.
So that's a huge development.
Yeah, I mean, a shout out to Ben Constable at Microsoft. He's the principal engineer that wanted to see WebGL and IE, and he just drove the process all the way through, layers and layers of management. But it's looking good, so it's an exciting time. This year is going to be the year that your content runs on every device, basically, in every major operating system. let's keep it moving forward.
Not sure how much you played with Unity's WebGL exporter, but I'm curious how well you think that's going to work and how it's going to track all the changes you're talking about and the advances that are going on.
Looks good. I mean, have you seen the Dead Trigger 2 demo that they showed at GDC?
Yeah.
It's pretty good.
How big's the JavaScript?
It's pretty large, tens of megabytes, I think. But
Yeah.
it's mainly
It's unscripted,
classes.
that's what's going to happen.
Yeah, that's right.
There's no way around it. Until
No
the
way.
browsers cache the heck out of it and give you more support for it. It's just, the reality right now is you've got to download machine code, basically, that's been cross-compiled to JavaScript, and it's a big payload to get the engine. Right? Unlike, say the artillery engine, which is what, 500 kilobytes?
And
Ish.
part of our engine is using ASM.js now.
All right.
But, okay, but it's
Fair.
small, right?
Small parts.
Yeah, and overall, I'm saying the footprint is small. So that's one of the big issues, right? But once you wait for that download, the thing screams, right?
Yeah, it's really not doing any memory allocation at runtime, which is plus and a minus. They do this massive pre-allocation at the beginning of time, and the app cannot use more than that amount of memory. But it's gonna be very fast, pretty much across the board, because even if the JavaScript engine isn't that sophisticated, doesn't optimize away object allocations, it's still going to do the integer and floating point arithmetic really fast.
So, if you're building an MMO or some other high commitment game, other high commitment game, Unity might be a good choice, right? Because your users presumably are core users, they're committed, they're okay watching that download bar. It's going to be 2, 3, 5 minutes, right? Could be. Maybe not even. It depends. I mean, the early Unreal demos were like that. It was like 2, 3, 5 minutes, But they're going to wait a while, right? If you're like Teo and want to put some data up with a graph, there's no way that's an acceptable experience, right? You're not even going to have a 2-minute experience in there. You're going to have a 5-minute experience in there. You're not going to wait the 2 minutes for the download. You need that stuff to happen instantly. So it really kind of depends on what you're doing. But if you're building a core game, you're willing to wait for those load screens, it's a great way to go. And the stuff I saw was I didn't see the SIGGRAPH demos, but the showreel stuff I saw was pretty impressive. So it's just looking better and better. You actually tried it on, do they have any public demos you can hit so you can try it on the Tegra?
I haven't tried them on the Tegra. We should
do that, yeah.
Yep.
It's really exciting stuff. So yeah, everyone knows now Unity's publishing with WebGL for free. They announced that you don't have to have a pro license.
I thought that was okay.
No, it's not. It's been announced. It's all over the spheres. They're talking about it like a week ago. So that's a good thing. That's great. Anyone else have more questions for Ken, because we want to get rolling on to the next speaker?
Any cool stuff at SIGGRAPH that we should have a look at? Or a link to that? I mean, or what's the name of something? Things?
There was a lot of cool stuff on better, more photorealistic global illumination techniques and ray tracing techniques. There was a pretty cool paper on voxelized shadow volumes that might actually end up in WebGL, because it's like uniform resolution shadows for your entire big scene with actually not that much storage. The only problem is it takes a few hours to pre-compute the shadow map. So it doesn't support dynamic light sources, but it's a good idea.
Was there anything in the WebGL bits that we should have a look at?
All the presentations are on the WebGL wiki.
Wiki, right.
So please hit the wiki. And
Steve Witten's thing was kick-ass.
Yeah,
The presentation he did it in WebGL. It was a live slideshow with WebGL embedded right up your alley too.
And
It's one of my heroes.
Killer.
And that is already on the wiki, so you can already see his SIGGRAPH presentation.
He's like Tufty reincarnated. Yeah, he's awesome. Thank you,
Yeah.
Ken. One more.
Yeah, I was also there, and
Yes.
I gotta say there was a lot more WebGL related talks and courses than last year, which is good. And one of my favorites was WebGL in Education. That gathered a bunch of professors who teach computer graphics, and kind of like the TLDR is that professors are really stoked about WebGL, and they love teaching students computer graphics for the first time using WebGL, because it makes it much easier for them to kind of like get into it right away and get some feedback, share their work with other students, which essentially means that like 3 to 4 years from now, you will have a lot of graduates from computer graphics universities that do WebGL.
That is awesome.
Also, Kabibo introduced the real-time live session with Webby written in WebGL using Leap Motion to interact with it, and that's also linked from the WebGL wiki.
WebGL for a Webby Awards thing?
No, real-time live. The
Oh,
interactive
real-time.
session, he introduced it, so he was the keynote speaker, basically, and he did it in WebGL. It was amazing. It's looking good.
Excellent. Thank you, Ken.
Thanks.
On the subject of WebGL everywhere, I just want to make sure we all know it runs on iOS now, right? iOS 8 beta, just in case we didn't catch that memo. That's
How's the
huge news.
performance?
It's pretty damn good on my my iPad Air. I've checked a lot of stuff out. I found one demo that was doing something wrong in a shader with some environment mapping or something, but everything looked right, and I didn't see any frame rate issues. Like you run the usual canon of demo. I haven't tried running an artillery game, but you try hitting all the usual suspect demos and they all work right. Yeah, pretty amazing. Like no jank, no nothing. So I haven't tried it on my phone because I'm afraid to put the iOS 8 beta on my phone. I actually use my phone. But the iPad seemed like a safe place to do that. Okay, guys. So now it's time for our featured speaker. You're all plugged in there? No, not quite yet.
Oh wait, is it?
Yeah, you need to
You got it.
get your screen up. And while you're doing that, I'm going to introduce you. So this is Joe Eagar. Have you actually been to one of our meetups in the flesh before?
No, this is my first time.
Excellent. Well, welcome. So Joe found me and suggested this meetup topic, which is great. I love the meetups thing. You just go on the site and suggest a meetup, and we decided to do this one. And again, it's about subdivision surfaces in shaders in WebGL without needing a geometry shader, which is a big deal. And Joe's going to tell us why that is. And I'm just going to give you a quick bio on Joe, which I have to read from a cheat sheet here. All right, so you work at Bosch. What does Bosch do?
It's like the German General Electric.
That's a big thing.
They
Okay.
do so many things.
Do they also own television and microwave programming like on 30 Rock? Or is it just
who knows? They do so much. It's crazy.
But you've also started your own company called Altshape.
Yes.
So you make a WebGL-based modeler, and unbeknownst to me, Joe actually contributed or built a new modeler, right? A new mesh modeler for Blender.
Yeah.
So is that out yet?
It is.
Does it have a name, or is it just like you usually go to the menus and you say mesh modeler, and that's your...
Yeah. I actually replaced the existing tool set.
And then when is that actually going to go into release? I mean, what phase
it was
is it in?
released, I think, 2013, 2012.
Oh, so it's out. So if you get
Yeah.
Blender 2.6 or dot something or higher, we're using your model.
Yeah.
Wow, that is awesome.
Yeah.
You're in the presence of mesh greatness.
I spent 9 years on it.
Wait,
Nice.
9 years?
Yes, 9 years.
And you learned to program when you were how old?
16?
Wow, that's awesome, man. That's great. Well, without further ado, Joe Eagar is going to talk to us about no limit subdivision surfaces in WebGL. Take it away, Joe.
Okay. So first, I'm going to do a little demo. This is running, and yeah, this is running at 30-40 frames per second on my crappy GPU. And as you can see, it's like, it's like, you can interactively edit and this is not quite cooperating, so I'll just go to the presentation.
Pretty good to me.
Yeah,
It's good.
Oh yeah, this is my 3D modeler that's written in WebGL.
Woo! Is that available live online right now?
Only to select few. I'm in the process of trying to sell it.
Okay.
Why is this on? There we go. Presentation. Okay, what does it do? Let's see, does this thing work? Or does this
That
thing-
lifts that back up.
Oh, it's
actually.
Yeah.
What are you trying to do?
I just want to see if a little. I guess not. I kind of expected my computer to be like next to the screen.
I can move forward if you want.
Oh, you can?
I mean, no, I just mean like you say next, I'll press next. Is that what you're talking about?
Oh,
Use arrow keys, no?
yeah. I could have sworn that HDMI had something where it would like automatically. Okay. Oh yeah, that'd be good. Yeah.
Actually, I think we should raise the screen so that it hits the. Which one did you use to raise the
White
screen?
one, I think, right?
Yeah.
Let's just get the top of the slides.
Can you stop it at the right moment?
Yeah, I think so.
Well done.
Good, good.
Nice.
Woo!
Roll it.
Nice.
Best technical pitch.
Could you go to the next slide? Okay, so subdivision surfaces are the current kind of industry standard for kind of smooth surfaces. Mathematically, they actually suck, but it's much easier to code them, and especially it's easier to code them in a way that artists find easy and natural to use. They're actually an approximation of Bezier surfaces, which is why they suck. And and if you talk to 3D modelers, they'll tell you all about the problems of it. But you know, it's used for movies and games. And next, and the process, as outlined in the famous paper, is that basically you subdivide and then you smooth the vertices with a simple averaging approach. And so you kind of subdivide by one to smooth, and then you subdivide again to smooth, and you do it again. Next. This, unfortunately, has problems. You're wasting your computing resources. We don't need to store the final subdivided mess explicitly. I mean, like, let's face it, even DRAM is horrifically slow. Like, it's better to try and limit the amount of geometry that we're storing and moving around main memory and across to the GPU. Next. And of course, there's the alternative, which we all love, the geometry shader. It's the most awesome thing ever. It just isn't supported by WebGL. So.
Can you explain to people what that is?
The geometry shader lets you create tessellation on the fly. Like Pixar's open subdiv library uses it. And it's a really awesome thing. You can subdivide right up to the limit surface with pixel perfect accuracy. But we need a different approach for WebGL. Next. And so we want to approximate subdivision surfaces without geometry shaders, without storing massive amounts of data. Because not only is the GPU slow, main memory is also slow. Few people realize this. Next. And so we're going to use bicubic patches, which, since subdivision surfaces are approximating a Bezier surface, you can represent them with bicubic patches, which are this weird little thing there. And we're going to render them at a fixed tessellation resolution. Next. And to render these patches, we are going to have one vertex array, and it is going to be a two-dimensional array with UV values that will go from 0 to 1. There's going to be no actual geometric data here. It's just a 2D grid. Next. And then we're going to store the patch control points in a texture. And next. And the advantage of this is, of course, the big one is the saving on memory resources, and also that you're not limited to powers of 2, which is the other really annoying thing about recursive subdivision. Next. And so, to generate these patches, I use this paper by Microsoft. Next. And basically, a bicubic patch is just like a patch that's defined over kind of a UV space, 0 to 1 in U and V. Next. And so to start, I do one subdivision and smoothing step, so that I have so basically to quad relate the mesh so that there's only quads, because we're going to be generating quad patches. And then each patch is based by applying a weight map to a section of the topology. Next. So you might have like, you might have a corner bird which kind of averages surrounding vertices using this mask. And these diagrams are a little misleading because, they're actually variable, like size, like, wait. Oh, that's wrong. Sorry. This is an edge mask. You have your like little edge point, and you like look around the surrounding vertices, and you weight them. And all of these weights are normalized, so you're not actually multiplying them by 4. Or it's just kind of used in the paper instead of having like floating point decimals. And extraordinary vertices is the same thing. Next. Now this does have problems in that it doesn't create good normals around extraordinary vertices, which I did not implement the author's solution, which sounds kind of neat. They basically make a special, like, kind of 2-dimensional normal patches that they call tangent patches. But I didn't do that because I didn't really need it for my purposes. Yeah. So the points are patterned to a texture. And I really wish that OpenGL supported 1-dimensional textures, because I hated writing this. It's like 30 lines of code just to convert from the 2D coordinates to a 1D coordinate. And next. So to draw, you load the one pass of the 2D vertex array grid. You go through, and you load the texture of control points. And you go through and you feed the current patch index with a uniform variable. You then draw with geo.draw arrays, and then you just repeat this. And this is where Google's instancing extension sounds useful. And the nice thing about this is you don't have exploding RAM use. It's really the killer of the original algorithm. And next, is it? Oh, I see. And that's the end. And I guess I'll try doing the demo again.
What was that URL?
No, this is just on my local computer.
When will it be on sale?
I'm trying to sell the company because I don't really like business.
How many features do you have compared to, say, Moto or something?
It's actually, it's relatively cool feature. Like, Moto is insane. I guess maybe compared to like Silo or.
Okay, yeah, just the modeling part. It would be similar to Silo?
Yeah, though, it's not like physically safe. It doesn't have as many features as I did for Blender. Partially because I was trying to support like kind of more CAD features that architectural visualization people want.
So it says 82 verts here. How many actual vertices are you pushing to the GPU to render this?
Well, 82, right? It just pushes them over and over again, the same ones. And that's what produces the selection.
Well, it's not saying the number of triangles that are being pushed to the GPU. It's just the number of like logical mesh.
So, are we looking at a subdivided mesh right now, Joe?
Yes.
Can we? Is there a way to display it with pre-subdivision from its crude, I'm assuming, box shape?
Now, beyond extruding a face, can you drag a point and
It's not. Yeah.
there we go.
And,
Yeah.
Can you crease the edges?
not yet. I haven't done that. Although I guess there's always the trick that some artists prefer, which is just add an edge loop.
Is there a lot of creasing done with this type of modeling anyway? I mean, it's not a competition. You model the edge as opposed
Most
to
3D modelers kind of prefer to do it manually with duplicate edge loops.
duplicate the edge. Changing the topology. Can you do a quad chamfer, like a corner? Like leaving it, let's say you catch 3 edges meeting at the corners and then chamfering them, but without, it's
No, I've not done that tool.
Do you see a possibility of doing a multi-resolution approach? So patches farther away would be tessellated at a lower resolution.
I could. It would just involve having a few more patches.
Okay.
You think is a dynamic LED technique? You're saying?
Yeah,
That sounds great.
thinking that it would save some triangles potentially.
Yeah.
I
And
totally want to use this.
Yeah, this is awesome.
Yeah.
well, if someone wants to think over all the business aspects of having the especially I was getting to the point where I was going to have to get funding and hire people, and I wanted to avoid management until I'm at least 40.
So Joe, so we're not. The triangles that we think we're seeing, we're not seeing. There are not triangles in that mesh, right? We're just seeing the vertex points that you're drawing here. Those are the only vertices that are stored as data. Yes.
Yes.
Right. So everything else is being done in the fragment shader.
Yeah. In the vertex shader.
In the vertex shader. I don't get that though. How do I see a curved edge along the edge of that model?
So what I
It's
gathered-
because the edge is. Sorry.
So what I gathered is you have the existing triangles, right? You just make them really small for every part of the grid, and you send them over, right? So you draw like this little part of the triangle, and then this part, and then this part, right? And you just go down, draw all the triangles of the mesh with a single mesh, but just drawing it multiple times with making the triangles small and then offsetting them to where it is supposed to be based on the data in the one D.
Oh.
So you basically
I
have
didn't get that.
one draw code per face.
Yeah. Well, one draw call per quad on the
on the base.
On the base.
Okay.
So if we zoomed in royally into one of those,
So you're rendering like 256 draw calls per frame or something.
Oh yeah.
Yeah, it's always smooth.
Which is
Yeah.
which obviously has limits, but
It works.
Google seems to.
It's awesome.
Yeah, it does. And I got this from there was 2 sentences on Stack Overflow that was like, oh, why don't you render it in one vertex buffer and reuse the same buffer? Those are the 2 sentences. Previous month writing a extended GOSL language compiler to extend WebGL GOSL. I had done all sorts of stuff, and I just threw it all away because I was and I realized this is not hard. I felt so like dumb for like, you know, like writing a whole language from scratch that was going to like let me do 32-bit floating point math. Now I have no idea why, but this works on half floats.
Oh.
I didn't think it would, but it's cool because it works on mobile devices.
Cool.
This is actually still semi-interactive on a cell phone. Which I really give kudos to the WebGL people, because forcing us to design a new API to force us so that it would work on mobile devices was so helpful, because it just worked.
Yeah,
That's amazing. It's like if it works on your desktop, like it'll work. It's not hard to get it to work on like a cell phone.
Yep.
It's so cool.
Thanks to the OpenGL working groups, you know, really.
The other thing with the changes in the topology, say if you import a mesh, arbitrary mesh.
No.
you-
There's no topological limitations. This is a very flexible structure. Like it supports holes and faces, which is something that architectural people really need. Like I always felt bad because in the lender we always had to tell the architecture people that, you know, we couldn't really support that kind of work because they have to have holes and faces, and we that was never part of our data structures. And holes and faces is just where you have like, you know, you have like a polygon, and then you have like a interior loop that kind of cuts out a hole in it. And if you're doing
I think we call them
anything with
windows.
architectural visualization, you have to have this, because otherwise your models are become impossibly to deal with.
So do you define that hole by like a vector shape defined in a square space, and then
No.
it's just
No, it's just it's just defined as 3D points, and it's projected to onto the normal plane of the face. Because it's easier to store that sort of thing like in 3D space and then like project it back, because then you get the benefit of it, all the affine transformations, they all work on it properly.
Question. So what precision do you need in your 1D texture? I mean, you said you use half floats. I assume that you're using half float textures for the information that's stored in the 1D texture?
Oh, actually, I'm not actually sure. I assume the texture, I mean, like, unless all of my devices support 32-bit textures, I assume if you, so if you use the floating point texture extension, does it always use 32-bit floats?
Yeah.
Oh, I did not. Well, the vertex shader uses half floats.
Okay.
But I guess if the texture uses 32-bit floats, then that might explain why it works.
Okay. Yeah, that's true. Huh. This is cool.
And if you combine this with Google's instancing extension, you could theoretically have this in game. But note that for game purposes, you wouldn't need to do the thing with the tangent patches, because otherwise you can't have displacement mapping. So it's slightly more complicated when you have to deal with, like normal mapping and whatnot.
Have you tried, texturing the resulting mesh?
I'm not actually.
Okay.
It shouldn't really be all that difficult.
Yeah. Parameterization is very uniform.
What's the limitation for normal ones? I mean, if you have the, if you can map it, if you have the triangle display.
Well, because you have to have a continuous normal field. So you have.
You have breaks within your topology, right? But it will still work where it's continuous.
Yes, it will.
But that comes down to just planning the mesh, right? Not
Right.
the limits. Oh.
But you cannot build a organic. You can't build a humanoid character without. What is it? Like on faces, you have to have like at least 2, 3 balanced intersections, and you have to have like what is it? is one 5-sided vertex for a face. That's because you have to have a certain number of extraordinary vertices in a mesh. Just because if you limit yourself to 4-sided vertices, you get a torus, which is not very useful. Like literally, it forms a donut shape if you try to make a closed surface. So you can't avoid the vertices that have fewer or more than 4 sides. Although I didn't actually test that. I mean, like, who knows? Maybe it does work, but that's what the authors said, and I kind of suspect they're right, given that this is Charles Loop and Scott Schreiber, wasn't it? Yeah, who are pretty big names in the subdivision surface field.
So we can't use this online. You just came here to tease us. Just diddle us. Get us all excited, but not. What? So what's the plan? So can someone here buy his company and release this stuff already?
Well, I was thinking of coming up with just a little library for the subdivision surface part.
As opposed to the whole model.
Yeah. Which I just need to talk to people about how such a library would work, such that they would use it.
Yeah, I mean these interactions with text string and other things for some applications that they're not showstoppers, right? I mean, they could be worked out with a little more work, right? So if you release that library, someone could probably figure out how to do UV interpolation based on the same algorithms, right? That's what it comes down to, right?
I'm actually planning on releasing large portions of this thing's code because I wrote a lot of my own libraries. It's just the application as a whole I don't want to open source it. But the subdivision surface part, there's lots of internal things, which file serialization. The way it saves files is kind of, I think, better than JSON. I didn't have a choice. JSON wasn't working, so I had to come up with something better. I wrote 2 different things, and on the third one, it worked.
Probably not XML.
No, it's all binary.
Yeah. That's really awesome. Yeah, if you release this code, I think a lot of people are going to be excited about that. Obviously, I understand you want to, also want to try and get some business done around the overall modeling package. That makes a lot of sense. I mean,
Yeah.
And there are other open source modelers out there, but the thing that
one of which
really,
I wrote.
Yeah, one of which you wrote, in fact. That's a very popular one. But that subdivision, it's just great. I mean, what you've done is you basically. The light dawned on me. When I tend to think about these things, I think there's a mesh there. There's vertices. Everything you see here, there's all these little bitty triangles, right?
Yeah, but they're there, right?
But they're not. But they're there. But they're not there.
Exactly.
They're there when he draws over here, and then they're there when he draws over here, right? It doesn't ever all exist at once.
And
He needs to use the memory.
That's the cool. Because
That's the cool part. It's just drawing really fast.
Because the one thing your
which is what
computer
WebGL
science professors will never tell you is that memory is the slowest thing. Especially with multiprocessing, main memory is slow.
Hard drives are slower.
Main memory is still pretty slow, and especially with object-oriented languages are not compatible with the way that DRAM is designed. It dawned on me when I realized why the lender is just faster than everything else. And I realized it's because we were programming it in a procedural, language, C, and it forced us to follow the hardware. So if you can limit, how much data you're moving around, it really helps. Especially, like I said, it's an object-oriented language, which doesn't deal well with these bandwidth issues to begin with.
So technical question for you. When you, at the beginning of the subdivision, is there a setup step? I mean, do you start by doing some pre-process, or is it,
Oh, yeah.
you just start with simple mesh, number of subdivisions, and feed it, or do you do a CPU-based sort of
Oh yeah.
analysis first? Can you
Yeah,
talk about that a little bit?
yeah, there's a CPU-based analysis. So it has to build the patches by kind of looking through the topology, and unfortunately I forgot the exact details, but basically,
Yeah.
the paper was confusing, and then when I implemented it, it was one of those things where like your head explodes when you implement it, and then you can't quite remember how you did it.
Okay, just don't try and look from underside of the model, right? Yeah. Everything looks fine everywhere else. No, I'm just kidding. Okay, yeah, so you have to analyze the topology.
Yes, and you have to do one subdivision to turn it into quads. And then you build the different points by like going around and averaging them, and using this mask. And actually, what I ended up doing was slightly different from the paper, which is why this is why it's so confusing to me, because I read the paper and the paper seems to disagree on some points. And so you do have to do pre-processing. I do try to do it incrementally, so I'm not like, so it's only processing like, patches that have changed, because it's kind of slow to actually do all of the patches. And unfortunately, it still has to like do a lot of them. Like if you move one vertex, there's 16 quad patches around it. Then around those, there's even more, and you have to do all of them. So there's however many that is. There's there could be like 60 or more patches around a single vertex that you have to update. If I'm getting the math right.
But then once you got that, you're good to go.
Yeah.
Then it's just a matter of rinse and repeat on the number of subdivisions you do.
So I imagine that a triangle would not be supported, but you could simulate one by moving two Beziers very close together, for example, with a wedge.
Well, what I'm doing is I'm just, because I'm subdividing the mesh first, the triangles all turn into quads, into 3 quads. Actually, you can have, triangle-shaped, patches, but I just don't support those at the moment.
Joe, have you talked to David Holtz at Weak Motion? You know about Weak Motion?
Oh yes,
Because they've been showing apps where people use their fingers to do the stretching and pulling and wiggling that you've been doing.
Oh yeah, actually before I did this, I interviewed with Weak Motion. So I'm sure I've talked to him, but just not about this.
Because they are showing apps like this,
Yeah, there's.
but not as fast or as sophisticated as yours.
Well, there's one called Clara.io. They don't have this subdivision algorithm, but they have lots of cool features.
They do, yeah.
Yes, and they're the people I try to sell it to first.
Okay.
Have you written any of this up? I know you got the video demonstrating the stuff on YouTube. Have you done a write-up that sort of starts with the Catmull paper and then goes from there into the specifics of the WebGL implementation? The kind of stuff you gave us a presentation on today. I think that would be really incredible for people.
I should do that.
You started a Weebly site.
Oh yeah.
You're starting to document this.
Yeah, that was mostly for resume purposes. I'm not quite sure how to go about that. All of the stuff I did as an alternative to college with which my health prevented me from going when I was younger, and which is now too low of quality to be worth it. No, literally, my parents stopped bugging me about this 2 years ago because it's just not worth it anymore. Maybe someday I'll go through Stanford's grad program, but. And so I've never really written a paper, and I don't really know how to deal with the journals, and like people were talking about which ones were prestigious. Because if you're an engineer, they all seem equally crappy. I'm sure you've had to deal with the quality of computer science research is not terribly great.
Wow, that thing's durable.
Yeah. People must have questions for Joe. Guys, have at it. And gals.
Where do you see yourself taking this? I mean, aside from selling the company, do you plan to work on refining the quality? Do you plan on expanding the modeling tools? Like, what's your plan?
This was originally targeted at the 3D printer market.
Cool.
So, I wanted something that was easy to use and that had all of the features of that had all the features in the data structures for all possible markets. So like the holes and faces that the architecture people want. And I still think 3D printing is an exciting area to go into, just because like there's kind of a lack of quality like software for that. Unfortunately, there is a problem that this is not suitable for commercial manufacturing because, like I said, Bezier surfaces suck mathematically. So, like car companies will never use bicubic patches because it messes up the curvature of their designs and like the reflection lines get all off and they really hate it. But I'm thinking that the consumer market won't care about the fact that they can't get perfect glossy reflections coming off of their car-shaped toys, and that I can target that and like people who just want to do make practical things at home. That's what.
Since you said that you're basically having one draw code per patch,
yeah.
Kind of makes me wonder how well does this scale? Because it's not unusual for models to have tens or hundreds of thousands of polygons.
Yes, there is a scaling problem. I mean, it scales much better than I expect, mostly because OpenGL caches draw calls. However, the instancing extension sounds like it could resolve this issue, where you could have just one draw call and it would just go through all the patch parameters and draw all the patches.
No, so isn't the reason they have those millions of triangles because they're subdivided and then stored, right? The problem is
Oh yeah, the base mentions are
Right, but sometimes base mentions can be hard.
Any other questions? Well, the guy in
You
the back.
wash exactly?
Well, I'm not allowed to talk about it.
Best answer.
Yeah, I can talk about the boring math stuff, but not about why we're using the boring math stuff.
Is it WebGL related?
Yeah.
Mostly.
Yeah. Any other questions?
Have you tried adjusting the resolution of the tessellated, pre-tessellated patches, and what kind of frame rates do you get as you?
The frame rate does go down if you have too fine of a tessellation, and this will actually adjust the tessellation based on the number of faces, so that you get it turns out you can have an approximate limit on the screen size of the triangle or rather, sorry, you can limit the world space size of the triangle by kind of this equation that involves taking the logarithm of the number of faces, and then basically as you subdivide the mesh, it uses coarser patches to try, and it actually does end up with a relatively constant triangle size in world space. So as you subdivide, it automatically makes the patches less dense.
Globally on the object? Or
Yeah.
globally.
Yeah.
So if I can just run through it one more time for myself to make sure I understand it correctly. You're making one draw call for each quad patch, or one draw call where you draw one like small piece of each patch in each draw call?
One piece per quad. One call per quad patch. Yeah. It helps that the vertex arrays are two-dimensional, because the quad patches are, basically their parameters are u and v, and then they calculate a 3D coordinate. So it uses less space.
So how many draw calls to draw that object we're looking at right there, roughly? 72.
What's 330
Did you say
like 4?
256?
30 frames per second?
So maybe about 1400. This actually runs at like 60 frames a second on a desktop computer.
Draw calls.
1,400 draw calls are driving that mesh?
Let's see. If there's 660 triangles, that would be like 330 quads times 4. 300. Yeah.
1300.
Keep in mind that OpenGL does cached draw calls, which helps. Like if this was like Direct 3D, it would not work. And you can actually see the difference if you insert a gl.finish call between each draw call, and there will be a major slowdown.
Why are you stuck with Beziers? Why can't you also use NURBS as well?
I'm
But then you
thinking
wouldn't have the reflection problems.
I'm thinking of doing research into that because I actually have some 3D modeling skills, and it drives me crazy the problems you get where you can't quite make the right shape because it wants to make flat spots, and it'd be a cool area of research to do.
Yeah.
What tools did you use to make your web app and all your source code stuff?
This is you see, when I started, I went to the Tracer projects and their website was down. So I wrote basically Tracer. I wrote my own ES6 to ES5 compiler. And let me tell you, use Tracer. I mean, writing a compiler, writing something that full-featured was a pain. And it was just literally because their website was down that day.
You could have gone back tomorrow.
Yes, I could. It was funny.
Wayback Machine.
Yeah.
So it's all coded in ES6. Although you could do this in ES5, you would have to use the right programming patterns. And there are potential issues like, I'm not sure if you could do some of the same. There might be problems with the, for each kind of function calls that problems that don't exist if you're using ES6 because they designed the ES6 iterative protocol to be optimized. And let me tell you, when they changed the specification of the ES6 iterators, going through my code and rewriting it was not terribly fun. And I basically used just Notepad++. I can never find,
You're not the only one, Taylor.
I can never find, I mean, like, at work, they have this commercial program that's awesome, but I can never find free, you know, applications that are better than Notepad++.
Sublime text.
And I wrote pretty much all of the libraries. I think the only library I'm using is actually just a file compression library. ES6 has some language features that made the network code really, really easy. So I didn't have to use any, like, I didn't have to use jQuery or anything. And that's what I missed the most, is how easy it was to write network code in ES6. You know, now that I'm working on ES5 and work. And I'm thinking of releasing some of the libraries. I just, you know, don't really have time to maintain them. They also, you know, are in ES6, and I'm not, I mean, I can compile them to ES5, it just looks like, kind of like, you know, almost like assembler code. Because, you know, there's a lot of advanced features in ES6 that, you know, take up, that are very strange looking when they're compiled into ES5. Any other questions?
Are those divided, what, 32 by 32? Are they 1024 bases per patch?
Let me think. It's not a power of 2. They are cracked into a texture, and that texture is a power of 2, but the patch tessellation isn't limited to a power of 2, which is nice.
How is the portability of your code between browsers? Did you run into problems like with WebGL behaving a little differently here and there, or on different platforms? How was the experience?
Firefox has their ES6 features enabled by default.
Okay.
And Chrome did not.
Yeah.
And I found myself going to Chrome, and I'm like, and I was new to JavaScript,
Okay.
and I was like, oh wow, all the Mozilla web pages never mentioned that these features weren't in most web browsers. This is why I was looking for the ES6 compiler. This is why I wrote them, because I had already written a lot of code in what turned out to be ES6. Because just because Mozilla's web pages hadn't been sufficiently clear that these were extensions, not, you know. And of course, Chrome supports the 2. It's just they disabled it by default, which is smart. Especially since the specification has changed a bit. I'm trying to remember. There's issues with like touch events, but I think that's mostly because the standard has changed. So touch events still works in Chrome, but not in Firefox. I have to go through. I did have to heavily filter the touch events quite a bit. Although in newer applications I've seen, it seems to work just fine without any complicated filtering. So in terms of WebGL, there wasn't really a difference, I don't think. I mean, it's really nice. And the first time when I like loaded it in like my tablet, was like staring at it, like it worked. I'm like, how is it working? and that's because the WebGL standard forces you to code in a way that works on mobile devices. It's so cool. It was the coolest thing ever.
Another satisfied customer.
Fantastic. We aim to please.
And what's funny is I was always so lazy about OpenGL. Like, it's embarrassing, but I would still be using the OpenGL 1.0 API if I hadn't been forced by WebGL.
We all would, but
It's so much easier and it's also so much slower.
yeah. Yeah, I mean, this technique is fantastic, and the fact that you were able to, go from the research paper to a working implementation.
In a browser.
Yeah, in a browser is just amazing. Just great.
That is awesome. Joe, this is great stuff.
Oh, and by the way,
Really inspiring.
This whole app uses around 150 to 200 megabytes of memory on Chrome, which is less than a lot of websites.
Yes.
Awesome.
Wow. Are there any other questions for Joe? We need to wrap up soon. Time for another one or two. Jack?
Yeah, you mentioned that you render each patch to a texture. So does that mean that you have a panel on screen for each texture that you apply that texture to, like with alpha, and then they're all arranged in?
Oh no, the control points on the patch. So each patch has 16 control points, and they're stored in a texture.
Oh, I see. Okay. That's your 1D texture.
Yes, well, it's actually packing a.
And there's a patch index that's the uniform, and you just go,
Yeah.
you figure out which bit of the texture to get from the patch index.
And you actually should be able to arrange your patch data so that you don't have to, transform to a one-dimensional array. I just haven't done that because, it would be more work, but. Any other questions?
All right, let's have a big round of applause. It's truly amazing and impressive. I think I speak for pretty much everybody in the room. That's mind-blowing. Great work, Joe. Please let us know if you decide to put out the source code for that particular algorithm stuff, not the whole product. Somebody buy his modeling tool already, so he can go do more stuff in this realm with cash in his pocket. That's great. So thank you very much for making the schlep from Palo Alto. Thank you, Ken, for coming and presenting.
Absolutely.
Damon, as always. Marina, thanks for helping. And thanks for coming, everybody. There's a little bit more food over there and snacks, right? More beer. Let's try and drink that all up. And again, save those dates, September 25th, somewhere in the city, October 8th at Amazon in Sunnyvale. Stay tuned for those announcements. Thanks, everyone.